Hi, everybody. Yeah, I'm going to be talking about North Africa's first stegosaur and the armoured dinosaurs of Gondwana. So stegosaurs are a clade of thyreophorine ornithischian dinosaurs. They are characterised by this bizarre array of dermal armour that extends from the neck to the end of their tail. They're very, very well known from Middle and Upper Jurassic, primarily from the Upper Jurassic in Eurasian continent. So up here you can see a map showing broadly where we know stegosaurs from, and you can see that most of the occurrences are from Eurasian continents, up here, with just a couple of occurrences in Africa and one putative occurrence, which I'll come to in Argentina. Now, the sister taxon of the stegosaurs are the ankylosaurs, and the stegosaurs and the ankylosaurs are united in a clade called Eurypoda. And ankylosaurs are these small, kind of tank-like armoured dinosaurs which have these spikes, this array of spikes and plates all over their bodies. They were really dominant in the Cretaceous. They rose, increased in diversity and radiated in the Cretaceous as the stegosaurs declined. Now, once again, they're primarily known from the Eurasian continents. There's just a couple of occurrences in Australia here and one in Antarctica, but apart from that, they're fairly ubiquitous in Eurasian Upper Cretaceous ecosystems. In 2016, the Natural History Museum acquired a new specimen of a stegosaurine dinosaur from the Middle Jurassic of Morocco. And this is the first stegosaur from North Africa, indeed the first Eurypodon from North Africa. The specimen, these are some of the bones from the specimen. It's fairly fragmentary. It comprises some vertebrae. This is a humerus here, and a bit of dermal armor. And as you can see, probably from this picture, the preservation style is rather different among some of these elements. This material was acquired from a commercial collector, and thus we suspect that it probably wasn't a single individual. We don't have that much information about it because it was acquired from a commercial collector, but we suspect it isn't a single individual because the preservation styles indicate that it was probably from different layers. However, we do have overlapping elements with different preservation styles, and we do think this is likely to be one taxon, although really we'd like some more material to confirm that. So the specimen, the information that we got from the collector was that the specimen was from a place called Balmain and from the Jurassic. This is Morocco. These are the Middle Atlas Mountains. That red arrow is pointing to Balmain. It's about 75 kilometers southeast of Fez, and it's a little tiny village, as you can see from this Google Earth screen grab. And the Jurassic in the area currently it is exposed in two synclines, which you can see quite clearly here as well. There are two plunging synclines. This is called the Skura syncline, and this is the Nokra syncline. During the Jurassic, the Middle Atlas Mountains were a rift basin, and the sediments that were being deposited were shallow marine sediments, and also the area was periodically exposed. So we have some terrestrial strata here as well. Now, the sediments are extremely well dated through charophyte biostratigraphy to being Bathonian, and then the very top of it is Calovian. And the sediments here are known as the Elmers group. And dinosaur bones have previously sauropod bones have previously been reported from this area. So we think that our specimen is probably from one of these two synclines. And David Ward and I are going to go out here a bit later this month to try and have a look at the stratigraphy and the sedimentology and understand it a little bit better. So this specimen is significant not only because it's North Africa's first Eurypodon, but also because of its age. So during the Jurassic, in the lower Jurassic, we have our basal thyreophorines. So these are taxa like Scutellosaurus and Scelidosaurus. And then our first definitive stegosaurs appear up here in the middle, the top of the Middle Jurassic in the Calovian. So Loricatosaurus is from the Oxford clay, which is Calovian in age. Now this taxon here, Issaberisora, was described last year, I think, from Argentina. And at the time, it was described as a Neornithischian. Several of us who reviewed the paper at the time thought that it was almost certainly a stegosaur. And subsequently, we've recovered it as a stegosaur in a couple of different phylogenetic analyses. So it seems like it probably is, although I think that remains to be confirmed. Anyway, our specimen is here. So it's really old for stegosaurs, basically. It's one of the earliest stegosaurs that we have, if not the oldest, depending on the status of Issaberisora. So this is the material, as I said. We've got some dorsal vertebrae here at the top, and then we've got this humerus, some dermal armor. It's definitely a stegosaur. I'm not going to bore you with tons of anatomy, but it's definitely a stegosaur. It has a couple of stegosaur synapomorphies. So firstly, this is the dorsal vertebrae in anterior view up here. You can see how the neural arch is really stretched and elongated. That's really characteristic of stegosaurs. We only see that feature in stegosaurs. It's a stegosaur synapomorphy. So this is definitely a stegosaur. And this humerus is also definitely a stegosaur. It has this feature. This is the humerus in posterior view. And it has this ridge running down here with this kind of tubercle. It's called the descending ridge and the triceps tubercle. And this is a synapomorphy of stegosaurs as well. So clearly this material belongs to a stegosaur. It has quite a lot of autapomorphies as well. We might expect that, I guess, because it's from a completely new stratigraphic and geographic location. So I think we're pretty happy that it probably was going to be a new taxon. But it also has quite a lot of autapomorphies, considering how fragmentary it is. Firstly, we have very, very elongated pre-zygapophyses on the cervical vertebrae. So this is the cervical vertebra. That's anterior, that's posterior. This is a pre-zygapophysis, and it's quite oval and elongate. Normally, they're much more rounded. It has a very long blade-like neural spine on the cervical vertebrae. Mostly stegosaurs just have kind of nubbins as neural spines on the cervicals. But this one has a really long and apparently well-developed blade-like neural spine. It's broken, but you can see the base of it. And it also has epipophyses on the post-zygapophyses. So epipophyses, they're here as kind of rugose ridges in ornithischians. And they're really not known except in the anterior cervicals in most stegosaurs, or in a few stegosaurs, just maybe the first 3 cervicals. But this taxon, these appear to be more distal cervicals, and it seems like maybe these epipophyses continued all the way down the neck. And so that seems like an autapomorphy. We also have some rugose ridges on the front of the anterior centroparaphysiolamina. I hate saying that stuff. And they're sort of located about here. And they appear to be synapomorphies as well. And we've got a kind of triangular process behind the pre-zygapophyses of the dorsal vertebrae too. So you can just about see it here. But there's a little kind of triangular process. And finally, the dermal armor. So as I said, this material isn't associated, so we're not totally sure that this belongs to this individual. The preservation style is quite similar to that of the humerus and one of the vertebrae, so we think that maybe it does. And given that we have an armored dinosaur and we have some armor, it kind of makes sense that this would be part of the specimen. But we don't see armor like this in any other stegosaur. So this is pretty small. As you can see, the scale bar is 10 centimeters. So this is a little spike about 7 centimeters in height. And it's kind of either fused or associated with a scute, a hollow-based scute. So it's kind of sticking on top of this hollow-based scute. I have no idea in the body where this might come from, and we probably won't know until we find some more material. But certainly if this is belonging to this specimen, then it's totally unique to stegosaurs. So we popped it into Tom's latest version of our Stegosaur Phylogeny, and it comes out as in a clade with some European stegosaurs. So it's more closely related to our European stegosaurs than to the other 2 stegosaurs known from southern Africa, which are Paranthrodon and Kentrosaurus here. Now, given its early age, this position, the systematic position is quite important, because what it means is, although Issiberosaura, again, you can see it coming out as a stegosaur in this analysis, although, of course, this is a stegosaur analysis, so we haven't let it vary anywhere else. But Issiberosaura is the oldest, but it's also quite basal. So that kind of makes sense, whereas our Moroccan taxa is quite derived within Stegosauria. So we're kind of pushing back the radiation of stegosaurs, the origin and radiation of stegosaurs, really into the earliest middle to possibly lower Jurassic with this taxon. As I mentioned earlier, thyreophorans, they appear to be, or I should say Europodon thyreophorans, appear to be really quite rare in Gondwana. This is just a PBDB download, raw download, of Eurasian Europodon taxa versus Gondwana Europodon taxa through time. And you can see how many more Eurasian taxa there are. Now, there's a couple of possible scenarios about why this could be the case. It could be that we simply don't have rocks of the right type and the right age for dinosaurs to be found in Gondwana at this time. An alternative is we've got an anthropogenic sampling bias. We haven't been looking for dinosaurs in Gondwana that long or in the right rocks. It could be a combination of both of these factors. Or it could be that Uropodons genuinely were a rare part of ecosystems in Gondwana during the Mesozoic. So I wanted to just do some very simple kind of tests of this idea, or these different options. So I just downloaded dinosaur-bearing formations from Gondwana. So that's all formations in which dinosaurs occur in Gondwana. Dinosaur-bearing collections, so all places where dinosaurs have been found, all sites where dinosaurs have been found. And occurrences of Uropodon thyreophorans in Gondwana for the last 190 to 66 million years. And this is from the PBDB, of course. And you can see, like, visually, so the green curve is the dinosaur-bearing collections and the blue curve is the dinosaur-bearing formations. And you can see that sort of visually there's some correlation between them. And indeed, if we do some like simple stats on them, then we do find that these are correlated. And of course, that's what we would expect. We would expect that where there's more rock, more people have found dinosaurs. But when we try and look at the occurrence curves and its correlation to either dinosaur-bearing collections or dinosaur-bearing formations, actually there's no statistically significant correlation between any of these curves. And that could be driven by the fact that we have basically no occurrences throughout most of the Mesozoic for Uropodons. But I think that this might be suggestive of thyreophorans actually being a genuinely rare part of ecosystems in Gondwana. Now, why that is, I don't know. I mean, for sure, there's probably some sampling biases going on. But I do think that maybe Uropodons were a rare part of ecosystems in Gondwana. Okay, the Geological Society is about to fund the fieldwork that we're going to do at the end of the month. I just want to thank David Ward for helping me out with that. And thanks very much for listening.